Alex, tell me something funny.
Peanuts.
That's not very funny.
They're kind of funny looking. They're like an hourglass-shaped nut.
Yeah, I guess.
And they, you put them on a table and they kind of wobble, They're like... Whoa.
Do you have any Halloween plans?
I'm going to be at ATO the weekend before. All Things Open Source Conference, North Carolina. Come by the System76 booth if you're there.
Oh, right.
And if not,
That's
enjoy your Halloween weekend. Yeah.
Are you looking forward to that? Is that your first time going to All Things Open?
That is my first time at All Things Open, so I'm excited to meet the people, see the scenes, and get going in the open source space.
So they always have this social at a barcade after, I think, the first night they have it. And it's super fun, but it's right next to this rib joint. Well, I don't think it's meant to be a rib joint, but their ribs are really, really good. Maybe it is meant to be a rib joint, actually. I don't quite remember. It's been a couple years. Well, it's a really nice restaurant right next to the barcade, and I hope it still exists because I want you to try it if you go to that social event.
I hope so, too. It sounds delicious.
Yes. I have pictures of me eating ribs because they were so good. I wanted to take a picture. I don't do that very often, but they were picture worthy, even though ribs are pretty gross looking, but they were really good tasting. So
if you're listening, you'll see that picture on our social channels pretty soon.
No, I'm not going to post that picture. Or maybe I will. Yeah, it's kind of funny.
I didn't mean to volunteer you.
You just ribbing. Did. Yeah.
3, 2, 1, 0.
Welcome aboard the System76 transmission log. Our broadcast is about to begin. This is the latest on System76 computers, manufacturing, and Pop! OS. Now for your in-orbit crew.
We have a spooky episode for you this month.
We do? No one said I'd be spooked?
Not really, but it would be fun if we had some cool Halloween sound effects in between sections.
That
was your cue.
Ooh.
Yeah, that was your cue to insert a spooky noise in there. Because you have a really good zombie one, too.
Ooh, works. Oh, okay, I'll do the zombie one.
Nice.
I think my first one was better.
All right, Alex, what's new this month?
Well, we've got a Halloween sale kicked off, so that's $100 off select laptops. We've got the Lemur, Darter, Oryx, and Adder WS on sale. And for desktops, we have $300 off Thelio Spark, $200 off Thelio, and $100 off Thelio Major and Thelio Mira. So, very exciting. Get your new computer before our spooky season ends on November 7th, and make sure you get some discounted candy in the process.
Yes, you can find all these specials on our specials page, and you can find the candy at your grocery store.
Candy.
Alex, what's going down with Cosmic this month?
At time of recording, it's pretty recent, but at time of listening, last month we released the second alpha of Cosmic. For those of you who started on the first alpha, you'll just be able to update to it. We changed our release cycle, so we're having an alpha each month until we're feature complete, and then we'll roll into a beta. For Alpha 2, we built out the files application. We've got some important settings pages like Bluetooth and Wi-Fi. There's a Ethernet or wired connection page. All sorts of good stuff. We've laid the groundwork for accessibility, so it's not quite in a testable state, but it is definitely making progress. And there were some highly requested window management features. There's cursor follows focus. So when you open a new window, your mouse will just automatically snap to the top left corner of the window, so you don't have to move it there. Nice and efficient. And focus follows cursor. So if you hover your mouse over a window, that window will come into focus. So you don't have to click on it so that it gets focused. So just nice and efficient features, quality of life stuff. And I think people are really going to enjoy it.
Nice. I like that we're going to be launching every month, because my favorite thing in the world is when we launch new products. So enter Thelio Astra, a new member of the System76 desktop line, and the Thelio headband. Does everyone remember the Thelio headband? With their hit single flow?
It's been on my mind, Emma.
Oh, good.
So there's a new song this time with a new singer. Astra is the singer. And Thelio Astra is our new ARM-based desktop that runs Ampere processors. This desktop is a workstation for autonomous vehicle development, software-defined vehicle development, and ARM enthusiasts. It offers lots of cores at less power consumption and less cost. There's a lot of people out there who are going to enjoy that.
I think we should go into some more details, like specs for our nerds out there. Can I do my Price is Right spiel?
Please do.
Enjoy an ARM developer's dream workstation, the Thelio Astra. Specs go up to 128-core Ampere Ultra M128-33 GHz processor, 512 gigabyte octa-channel DDR4 ECC RAM at 3200 megahertz, NVIDIA RTX 6000 Ada GPU, and 8 terabytes PCIe 4.0 M2 storage.
Excellent work.
Enjoy having Thelio Astra on your desktop there. That's the end.
And I believe it will be the driving force for those endeavors.
I like it.
Our interview guests this month are here to talk about Thelio Astra and the engineering behind it.
Yes, we have Joe Speed from Ampere to talk about how Thelio Astra is being used in the autonomous vehicle industry. And we have Tony and Britton here to talk about the engineering work done to launch this product.
And now, let's go into the interviews.
Today we have Joe Speed joining us from Ampere. Thanks for joining us today, Joe. We wanted to start by talking about how you became connected with System76 and what you do at Ampere.
Sure, happy to. So one of the things I've always been really passionate about is grassroots open source communities. So I've been doing that stuff for a lot of years. I did a stint at Linux Foundation. If you're an IoT nerd and you use MQTT, that's partially my fault. The friends of mine invented it, but I spent years getting it made open source, and really like working grassroots community, working with enthusiasts and tinkerers and home labbers and makers with a lot of this technology. And then they turn around and they bring it into the workplace. And so for the work that I've been doing around ARM native, automotive, robotics, all these kinds of things, I know how important the developer community is. And I knew System76, you occupy a really interesting place in that ecosystem. And so I started over a year ago reaching out to System76, talking about getting something going. So Carl, Jeremy, folks, they got some Ampere gear in-house. You were using it in-house for like 9 months to develop Pop! OS for ARM64. You're doing some Raspberry Pi stuff, like developing, building, testing ARM software, mostly for Pi community. And that's at the point which you all decided that there is something there. And we got really serious about what can we do together? What can we do in a big way? So that's kind of my journey there with y'all. As far as Ampere, I had worked with ARM developing a reference platform for software-defined vehicle and autonomous driving. And we needed this kind of multi-core, many-core silicon for this program. And Ampere was the obvious fit. So I started developing products using Ampere, and then Ampere asked me to come join the company. So I'm the head of Edge. So the easiest way to think of that is I lead and drive everything we do that's not in the data center, not in the cloud. And so what we do around developer desktops, space, autonomous vehicles, 5G, content distribution networks like medical imaging, all of these kinds of topics. So putting dense compute, efficient AI, sustainable infrastructure out there in the world.
And I know you had your hands on one of our pre-production units, the Thelio Astra. What were your initial thoughts?
So you all do such brilliant work. Like I work with a ton of companies, and for a lot of them, it's kind of exercise of like, well, I had an Intel motherboard and now I have a ARM motherboard and I just stick them in the same chassis. And so I was super impressed with, I don't know if everyone realizes, the System76 products in general and things like Thelio in particular, these are not just built, they're not just assembled. Like these things are designed and thought about and engineered and tested in simulation. And you are doing this airflow, fluid dynamics, like hotspot simulation. And you really put a lot of thought into this. And it's kind of amazing. And I've spent some time at the factory there. So me and my buddy, Ken Peterson here at Ampere, and it's really incredible. It's sheet aluminum and aluminum billet enters the factory at one end and it leaves the factory as beautiful finished product at the other end. And to have that happening made in USA, that's a really big deal for me. That's so incredible.
And how did it compare to other machines that you've seen in the past?
Well, you guys know your product. They're really quite beautiful, right? There's a lot of craftsmanship that goes into this and quality. And it's for anyone who's listening to this podcast, it's no mystery, no surprise that you have some serious open source and Linux and firmware and desktop development chops. Something near and dear to my heart is the whole Rust topic. And so what you're doing with Cosmic, what Jeremy is leading with Redux, is incredibly important. And this will really resonate. This is important stuff for the community I live in, right? So things I do, like Rust is a hot topic within automotive. It's what everyone is trying to get to. And you guys are already there. So I think in a lot of ways, not just like physical hardware that you guys provide, but the kind of support and insight and upstream contributions that you all make, I think you can very much be like a Sherpa for a lot of these automotive technology companies.
Are there any specific configurations or adjustments that you make to make sure everything's running at peak?
In terms of the kind of configurations, it's kind of funny. Like what I've observed is, so in the market, you expect this bell curve distribution, right? But what I've seen is in this particular market, for the things that we do, it's like an inverse bell curve. Okay. So I see a ton of demand for like, how cheap can I get into this? How small? How low power? What's a minimal configuration? So I see a lot of demand for that. And I see a lot of demand for at the top end of things, like I want all the bells and whistles. I want all the cores, all the memory, all the networking. I want the biggest, fattest, most expensive GPU that you can physically fit into it and cool. And that's an interesting, fascinating thing. Something else that's pretty interesting is I've seen like within the home lab or hobbyist community, it was that demand for kind of the low end, like for us, cores are plentiful and cheap, right? We give a large number of energy efficient cores, fixed frequency, large private cache. As you scale it, the last core gives the same performance as first core. So, we make 32 core products, but as a practical matter, most people start with our 64 core. And so what I've seen in the home labber community is that, demand for the 64 core desktops, dev kits, all of these things compared to the 120 cores, like 2 to 1. And you're like, okay, that sounds about right. But something's really happened here in the past month is that the demand has flipped. And the demand for 128 core desktops, dev kits, all of this is double what it is for the 64 core. So something's going on, and it's not all home lab. Like I was just with one of the biggest cloud companies in the world, and it turned out that they had grabbed these boards and built a half dozen workstations for their mobile software team. And, and they're all like top end, top spec. So there's a lot happening that is not very obvious. And they went and, just got that stuff online. So interesting. So definitely, seeing a lot of memory, like anyone working on the LLMs, large language models, and these kinds of things, they're looking for, terabyte of memory, half terabyte of memory. You've got people like Jeff Geerling and others where they're using Ampere in their home lab NAS. And so it's, a lot of memory. And there's friends of ours just launched a product that it's, a portable compute with a petabyte of flash storage. So that cost all the dollars. And then the NVIDIA GPU. So, there's some really nice ones like the A400. If you just want to drive a bunch of displays and you're using, C Lion and VS Studio and all these kinds of things, that's perfectly good for that. And that's like $150. But at the other end, we're seeing people working on content and creatives and other kinds of things where, they're going all in with, even multiple RTX 6000 ADAs. Which very pleased that you guys can support that as well.
So you mentioned people were just kind of buying stuff offline and putting it all together. Well, System76 is trying to offer that as a single solution, a pre-built solution. What kind of value do you see in that? And what companies do you predict would be using this pre-built solution?
You've got the home labbers, and people are quite adept at hardware. And they love to build things just because it's fun, okay? There's also people who are ARM software developers. They just want to get about there doing what they want to do, and they're building them out of necessity. There's a big pent-up demand for these things. And so there will be people that continue to build these things and contribute and, work on firmware and all these other things. And that's an important part of the ecosystem. And honestly, we can learn and get a lot of insights from that. I ran a home lab ARM builder contest where, we could take a look and reward people that are doing really interesting things. The big demand, you look at, it's already public that Tier 4, which is a famous Japanese autonomous driving company, they're backed by Isuzu, Suzuki, Mitsubishi, people like that. They're doing stuff with Kawasaki, all of these, a lot of autonomous buses, a lot of autonomous movement of goods, like in factory complexes. So they already use your product. There's also, there's a Japanese automaker, big Japanese automaker who is in a lot of ways, commissioned for, I wouldn't say that Thelio Astra wouldn't exist without them, but it certainly would not exist now at this time. Okay, so they commissioned the development of this product for their autonomous driving team. And I think some of that might become public here pretty soon, but it's not yet public. We'll see if it's public by the time this podcast hits. And so, seeing a big demand and uptake in a few areas. So really anyone who's doing ARM software development, anyone who's end product runtime is ARM. And the automakers are a good example of that, right? So the vehicles are in mid-flight moving their electronic compute architecture from having hundreds of little cheap ECUs, so microprocessors, and MCUs, microcontrollers, running simple software, to a architecture, like when they talk about software-defined vehicle, they really mean cloud-native car. So think of this. In a software-defined vehicle, what you have is instead of hundreds of these little computers running a single piece of software, you have a few, or ultimately one computer that is larger, more powerful, multi-core, many-core, with complicated, complex software, okay? So think like, virtualized, containerized, like running things like QNX RTOS and automotive-grade Linux cockpit and Android automotive infotainment, like all on one computer in the car. So it's this heterogeneous compute, mixed workloads. You need this freedom of interference, and all of it's ARM-based. But you can't develop and test your software on that kind of hardware, you'd lose your mind. So most vehicle computers like Raspberry Pi class devices. And, as you know, like let's think of how many hours to build Linux on a Raspberry Pi, okay? So if you had to develop on that for a living, you'd go nuts. It would be too slow. So you've got to be able to develop and test at scale and deliver at scale. And this is a real challenge for the automakers. This is fundamentally like software delivery and quality is at the root of why Volkswagen fired their CEO. This is a boardroom level topic at automakers. And so, using Ampere, using things like Thelio Astra on the desktop and System76 Starling in the rack to be able to develop and test and deliver software at scale, right? Being able to get the same silicon that automakers use today on clouds and put that on your desk, that's a really powerful thing. It's an incredibly productivity improving thing. And, people say, oh, just do it all in the cloud. But, there are some topics where doing it on-prem has huge benefits and makes, like if you're doing driver development, you're testing different kinds of hardware and cameras and sensors and drive-by-wire and things. You can't do that in the cloud. You can stub it out. You can do 90-something% of your test, but you actually, at some point, you need physical hardware to do these things. If you're doing digital cockpits, infotainment, and instrument cluster, there's real value in having a dozen virtual head units running on your desktop with NVIDIA GPUs and being able to render it, capture it, stream it, share it with everyone in the office. That's huge. And I think that's where a lot of the uptake's going to be. Somebody that has exactly the same technical requirements and will use exactly the same hardware is people doing mobiles, right? Mobile app development and testing at scale and all of these things. And so, you look at the companies providing the core technologies for that, the mobile OSs and the people developing the apps, the people using the apps, the people concerned about the security of these apps, all of these things can be done on Thelio Astra.
What advantages do you enjoy about using an Ampere processor in a desktop?
There's people that kind of ascribe certain values to it. And for the cloud, it's really a matter of rack density and efficiency, right? To make your cloud business work better and customers happier and be more productive and profitable and hit all your carbon green goals, the exercises, you want more cores per rack and to use less power. So it's a density thing. Okay. Historically, a lot of the x86 was all about scale up. Like, can I make the cores bigger, hotter, faster, more powerful? Okay. With ARM, it's kind of more scale out. So, if I can fit a large number of energy efficient cores per rack, okay, that's good for the business, good for the environment, good for the bottom line. If these cores are fixed frequency, then they deliver predictable performance. If they have large private caches, then I don't have any of the hyper-threading impacts, and I can get good performance out of each of those cores. And then if I can put lots of those cores per socket and put lots of sockets per rack, that's the density. So here's the thing for desktops. This is how this translates. Because it's so energy efficient, think about this. You can take 128 core, put it in a desktop, and at 2.6 gigahertz fully loaded, 124 watts. So that makes it easy to cool. It makes it good on your home power bill. It means that it makes it really easy to make it quiet. So now I can have Thelio, I can get Threadripper class performance out of a Thelio, but it's super quiet and not using much power. And the other thing is, so think about within an enclosure, pick a number. Let's say I want it to be 500 watts. Well, if my CPU is using less power, then that means I can have more power for all the other things. So I can put hotter GPUs, more GPUs, and still keep within that same thermal and power limit. So I think that's a really big thing. Also, there are folks where they get sticker shock that, CPUs in the cloud cost, CPUs in the cloud with GPUs is hella expensive. And so there is a lot of flight, not just in the home lab or in individual developers, but like corporations and R&D teams and autonomous driving companies who end up like shifting these things to the desktop and to racks in the office because, they can rack and stack Ampere CPUs with NVIDIA GPUs all day long for a fraction what it costs to do that in the cloud. I think for general purpose compute, like just CPU, there's Hetzner, Oracle, there's a lot of companies that can give you incredible value. They do a really nice job, really nice product. But there is something to be said where if I need to physically touch the hardware or I need GPUs, there's not much that can beat that just putting that on your desk. Being able to do things like take a Thelio Astra and spin up 32 virtual 4-core mobile phone SoCs or automotive ECUs, car computers, and be running test in parallel, that has huge impact on your ability to do more tests faster because you can parallelize it. And if you can do more testing faster, that's more turns of the wheel, more complete testing per day. So I move from once a week to once a night to per pull request. I can do the full regression testing, and that's just going to be awesome for all of these people. So incredibly excited to be doing this with you all. And it's going to have a real impact on automotive quality, mobile quality. And, for vehicles, this is stuff, ultimately, like it saves lives, right? It gets better product to market faster. You're going to help with accelerate autonomous driving and democratize it so that more people can get into autonomous driving without having to front, $100 million in data center GPU. So yeah, it's genius.
Mm-hmm.
So we've talked a lot about Thelio Astra, but there is a really hot topic, is kite surfing. We heard that you were a huge kite surfer, so we were curious what that's like and if you have any cool stories for us.
Yeah, so kite surfing's rather brilliant. So I grew up from the age of 12 or 13 windsurfing. So I did that for a long time. And kite surfing came along and it's just brilliant. The first time I got to do it was in the Columbia River Gorge, Hood River, out at the event site on the sandbar. And, I was on a 5-meter 2-line kite, so no D-power, right? Like this is super dangerous stuff. And it was blowing like 30. And I went just tearing across the river, crash and burn, almost die. I'm like, oh my God, I love this. This is the best thing ever. And so got way into it, met a girl in Florida. She went with me on a trip out to California, kite surfing at Rio Vista, Sherman Island, and, jumped stupid high, came down wrong, just destroyed my knee. And, but, there's a bright side, which is after my surgery, she quit her job in Florida and came out and took care of me post-surgery. So I got a wife out of the deal. So now I'm like married, I got kids, I got a family, like it's awesome. So totally worth it. Totally worth it. The kiting is genius. The cool kids, they've definitely moved over to there's a lot of wing foiling. I'm not quite sure if I'm up for that. I like my surfboard. I like just tossing up the kite and going out in the waves. I highly encourage people try it. If you want to do it, buy a trainer, fly it for 10 hours, and then go take a lesson. Like that's the secret tip for how to do this well. And if you want to learn, there's no place better in the world than South Padre Island.
Okay. Well, thanks for that. I'm going to have to give that a try for sure. Right on. Well, thanks so much, Joe. We're excited to see what happens next. We have Britton and Tony here from System76. Britton, what is your job at System76?
Hey, Emma. So I am the mechanical engineer over at System76, and I'm responsible for pretty much all the mechanical design of the computer chassis and externals and pretty much the cooling systems for the computers.
Awesome. And Tony, what do you do at System76?
I am the product manager at System76, and so I do a lot of cross-functional work with basically every team at the company. And for Astra specifically, I've been working with Britton to develop the system.
Awesome. And that system that we're talking about is Thelio Astra, which has Ampere and ARM collaborating together, which is known for energy efficiency. So can you speak to any metrics that highlight the energy efficiency of the Thelio Astra?
Yeah, so we've been doing benchmarking that Joe has provided. And with the Ampere scripts, we've been able to do a lot of photonics testing, and it's performing really well over some of the more server grade CPUs. And it's really been, I think it's topped out. We've seen at 230, 240 watts, which is a lot lower than we see some of the other higher end CPUs. We're still doing a lot of benchmark testing. We're working with Ampere. They're sending new scripts and stuff over. So we're still testing like actual computer output through like a power perspective. But so far it's been performing really well for how much power it uses.
What are some of the challenges that go into benchmarking for ARM?
For us specifically, it's at least through my experience, it's been a kind of a software thing. ARM is a new platform for me to work on. So getting the software up and in a good place where we can actually benchmark it efficiently has been a learning process. But with Joe and the engineers at Ampere, they've been doing a lot of the heavy lifting as far as getting benchmark software ready. So that's probably just been the kind of main challenge there.
Gotcha.
And then Britton could probably speak more on like the cooling of it, because he did a lot of thermal testing here and pushing the CPU to its limits. So
Right, yeah. So on the thermal side of things, our initial testing, the CPU temp was a little bit higher than we wanted, so we had to do a few different modifications for the cooling. So we made our CPU duct a little bit larger, so it had a larger intake, so that more airflow would get to the cooler and allow it to cool the CPU more efficiently. And we also made some modifications to the rear exhaust fan, and the modifications allowed it to prevent recirculation of hot air and make sure all the air exits the rear of the chassis. But after those changes, we were able to get the CPU down to a more reasonable temp during the stress tests.
Can you speak to how well the system handles multi-threaded tasks or high-performance applications?
yeah, sure. We did a bunch of benchmarking through a Veronix test suite. And there was a test in specific called SysBench that was just a multi-threaded general computational test. And compared to the other CPUs that Veronix tested it against, it actually performed in the 96th percentile. So that was actually really, really surprising how well it performed. There was also a test for computational fluid dynamics where it performed in the 99th percentile. So
Oh, wow.
there's some tests that even ray tracing, it was in the 94th percentile. So it's performing really well in some of these tests that I was not expecting to see. And again, we're still benchmarking it and still testing the heck out of it. There will be a lot more. We'll have a lot more data as we get through these tests and things like that.
I'm excited to see some results there.
We're getting ready to set up a system now, and like Joe was talking about before, setting up a system with emulation and running some of their tests and really seeing how well it performs versus an x86 system emulating ARM software. Since this is a new platform for me, I'm very interested to see how well it performs because ARM has a very focused performance, and I'm just curious to see how it plays out.
Are there any other specific configurations or adjustments that you made besides the cooling that help ensure smoother performance, like the type of RAM or hard drive that you're using?
We've definitely been testing with all the DEMs populated, as that helps with the performance since it's an 8-channel. As far as drives, nothing too specific there. We've been running with our test system that we've been running in the factory has been using 64 gig modules, which has given us plenty of memory to run tests. We actually just started running a test that Joe and his team sent over, running a bunch of VMs, and we just got the results in on that. And some of these things are software specific as far as the versions and images we're using for Ubuntu. And those are things that are still currently being tested. So far, the performance is looking really good. And as we go further along and do more of these benchmarks and more of these specific tests, I expect the performance to be even better than at least what I expected.
And as far as the cooling system goes, changes did you have to make to accommodate for the Ampere chip as opposed to what we do in Thelios with Intel or AMD?
We chose a larger cooler than typical, so that itself required some modifications for just the CPU ducting, and that allowed the cooling of the system to be a lot more efficient and stay at a lower operating temperature. Like I mentioned before, that's like main part to really accommodate the CPU, and everything else was really accommodating for the larger cooler. And with the larger cooler, there's more like heat transfer, and therefore we need a little bit better airflow along with that. So that required a more efficient ducting system for the rear fan to prevent any kind of like air recirculation and stuff like that. So they all kind of work hand in hand.
Cool. Is there anything you want to add about Thelio Astra that you're most excited about, or that you think is the most interesting feature of the product?
One of the things we do really well is we have really powerful workstations, and we put a lot of work into optimizing them, and we continually put work into them. So having a workstation, a new workstation like ARM to add to the collection of what we already offer is pretty exciting, and especially working in a new platform, because I like doing new stuff, and having a workstation where we've been able to keep the size kind of down, because it's essentially a Mira chassis, is also interesting to have a workstation of that size. And it'll be interesting also to just go through as we iterate and then as we improve on the system going forward, and watching the kind of things that Britain comes up with to make improvements. We're already been looking into memory cooling, and so we've been experimenting with different things like that there. So just constant improvements and iterations, what I'm excited about.
Cool.
Well, that's all from me.
3, 2, 1, 0.
This has been the System76 transmission log. For more inspiration, check out the website and follow us on social media. On your descent back to Earth, please keep your hands and feet inside the transport beam at all times. Captain sign-off, in transmission.